Hello, dear learners. Today I welcome you for lesson 5 of chapter 2, that is kinematics. Here is the contact information. If you face any difficulty in this lesson, you can contact. The learning outcomes of today's lesson are that you should be able to plot and interpret a velocity time graph. You should be able to deduce information about motion from the shape of a velocity time graph. The contents which we are going to cover today are how to plot a graph, plot of velocity time graph, deduce information from the graph, and practice questions. How to plot a graph. In previous lesson, lesson number 4 of this chapter, we have discussed in detail that how we can plot a graph. So here are the steps for plotting a graph. If you have not listened at lesson 4, you can listen there. In this lesson, I am not going to explain this in detail. I am just going to cover this briefly. So while plotting a graph, we must have at least two physical quantities in case of two-dimensional graph. We must have the range of data of particular physical quantities. So here for two-dimensional graph, must have two physical quantities. So range of data must be of two physical quantities. Then we have to label each axis with particular physical quantity, and we also have to assign title of the graph. And before pointing the data points on the graph, you have to set the scale according to the range of data. So after that, the data points should be marked on the graph, and then join those data points to plot the graph. So here is the data given which we have to plot, and here is the two physical quantities given, that is one is time in seconds, and the range of time is from 0 to 5 seconds. And other quantity, that is second quantity, is velocity, and velocity is always measured in meter per second, and range of velocity is 0 to 50 meter per second. So last time we have plotted this graph of the distance displacement time graph on whiteboard. Now today we are going to see that how we can plot the graph by using any software. So today we are going to use MS Excel to plot the given data. So if you see here in this given data, we have seen that two physical quantities are given. We have seen what is the range here. So velocity is here a dependent quantity, and it is dependent on time. Time is independent quantity. So we will take time on horizontal axis and velocity on vertical axis. As in previous lesson, it was explained that why we need dependent quantity on vertical axis. So we will plot velocity on vertical axis and time on horizontal axis. So here if you see velocity and time is given, so the other quantity which we can calculate from these two quantities, if these two quantities are given, that is acceleration. So we will see that how plot is giving us information about acceleration as well. So now let's move towards MS Excel to plot the given data. So here what we will do, we will write the values in one column. So first I am going to take one quantity, that is velocity. I will enter here all the data which I have for velocity: 0, 2, 8, 18, and then I think it is 32 and 50. 32 and 50. And all these are in meter per second. And the other quantity which I am having, that is time. 0, 1, 2, 3, 4, 5, and time is in seconds. So we have the data here. This Excel will automatically set the range. So just what we have to do is we have to insert the graph, go to the insert option. Here you have the charts section. This complete section is for charts. Variety of charts are here, but the one which we are going to follow for the two-dimensional graph, we will go to 2D line and we will plot this stacked line graph. So we are going to select this option, that is stacked line. So once we have selected this chart area, we have to right click on this chart area. When you do right click here multiple options you will be having. So you have to click this select data. When we select the data option, what happens, this window will open. So here we have to add these data points, or you can say the data which we are having for two physical quantities. So I will click on this add button. When I click on add button, this small window with name edit series will open. So here series name is basically asking that you have to assign some name. So I am going to assign the title of the graph here, and this title of the graph is velocity time graph. So once you have written this name, series name, now we have to select the series values. So series values I have to enter here by the data which I am having. So I will select this cell and press shift and click on the down button, and you will be able to select all these values. Now you can see all the values are selected here. So now click on OK. What happens? Velocity time graph is going to pick only the values of velocity, the only for one quantity. For horizontal axis, the values are picked here by the default, but we have to edit these values. If you see here, it is starting from 1 second time, but if we see our data, in our data the time is starting from 0 seconds. So we have to edit this. So axis label range, we have to select this cell and mark it down so that all the cells are, all the data is shifted there. So press OK. Now if you see, it is starting from 0. Now click on this OK. The graph is plotted here. So what you have to do, you have to label the axis. So click on this plus sign, and then you will be having the Excel titles option, primary horizontal. So here we have time in seconds, and for vertical axis you have velocity in meter per second. Velocity in meter per second. So if you see here, velocity time graph title is assigned. We know that by seeing this title we can say that this graph is about velocity and time, and if we have velocity and time we can calculate acceleration as well. So more what you can do, you can active this data label as well, data labels. So I am selecting that this data call out should be selected so that we can discuss the data, the mark points which we are having on this. So if I make this window a little bit large, if you see here what is happening, here is the 0 second time on horizontal axis, and this is 0 is indicating that velocity is 0 meter per second here. So this 0 comma 0 is indicating that our first data point is lying here. After that, when time is 1 second, velocity is 2 meter per second. Here, if you can see, here is the time on horizontal axis, it is 1 here, and 2 is also that is of velocity. So if you see here, this Excel software will automatically pick those marks, will set the scale automatically. So what happened that here, if you see this line and this line, one box is having 10 meter per second value. So in between that, we will be having small values 1, 2, and so on. So similarly, for 2 second time, velocity is 8, and it is, if you see, 10 is on this line, but little bit down if we move, what happens, we have here 10 meter per second velocity. So if you now deduce information from this graph, that what is happening here, if we discuss that what is happening here, if you see, initially here velocity is 2 meter per second. From 0 to 1 second time, velocity is 2 meter per second. So acceleration is also 2 meter per second. If you recall acceleration relationship, it is acceleration is equal to change in velocity divided by time taken. So 1 minus 0, it is here 1 second time in this interval, and velocity, this is the final velocity and this is the initial velocity. If you take the difference or change in velocity, it will be 2. So here acceleration is 2 meter per second square. After time 1 second, when we see for next 1 second time, the velocity is changing. Now, how the velocity is changing? Either it is increasing or decreasing. So if we take the change in velocity again, so it is giving us 6 meter per second. 8 minus 2 gives us 6. And if we want to calculate the acceleration, we will divide it with this time. It will be 6 meter per second square. So here it was 2. Now 6 meter per second square acceleration here. So we can say that acceleration is increasing. Now take one more interval. Now here we have velocity 18, and previously the velocity was 8 meter per second. If we now take out the change in velocity, it will be 10 meter per second, and acceleration will be 10 meter per second square. So we can say that velocity is increasing here, and velocity is increasing, so acceleration is also increasing. This information we can get from this graph. Now acceleration is increasing uniformly or non-uniformly. So if you see, the difference at every second is different, not constantly acceleration is changing, so it is non-uniformly increasing. Acceleration is non-uniformly increasing here, or you can say velocity is increasing non-uniformly, not constantly or not uniformly. It is increasing non-uniformly. One more way you can see that from this point to this point, the line segment is very small, and for next interval, for next second, line is little bit large as compared to this one. For next second, This line segment is large as compared to this one. For next interval, this line segment is more greater than this one. So this increase of line segments are also indicating that acceleration is increasing, and as it is not uh, the line is not in linear form, it is non-linear, it is in a curve form. So here we are having non-uniform acceleration. Hope so it is clear to you. Now let's move towards slides. So we have plotted this data and we have discussed the information of the graph as well. Now see further slides. Here we have plot of velocity time graph, and data is given to us. What is happening at time 0 seconds, velocity is 0 meter per second. At time 1 second, velocity is 18 meter per second. If we take out the change in velocity between this interval, the velocity is 18 meter per second. And if we want to calculate acceleration for this interval, it will be 18 meter per second square, because here we have only the change of 1 second time. So after next interval, again here we have 1 second time, and how much change in velocity is occurring? It is 32 minus 18, it gives you 14 meter per second. So previously the velocity is change in velocity is 18 meter per second. Now here we have 14 meter per second, and acceleration will also decrease as change in velocity is decreasing. Similarly here 42 minus 32 gives you 10. So velocity is change in velocity is decreasing at every second. So we can say acceleration is also decreasing here. And if you see, the decrease is not constant, it is non-uniform or non-constant. So decreasing acceleration, or you can say the car traveling with decreasing acceleration but non-uniform. So if you see this graph, initially we were having change in velocity 18 meter per second, and so the line segment is large. After that it is smaller, then more smaller, more smaller, and more smaller. So it is non-uniform acceleration, and acceleration is decreasing here. Hope so it is clear to you. So here we have to deduce the information from the graph. One graph is given on vertical axis, velocity is given on horizontal axis, time is given. So if you see here, initially at 0 second, velocity is 0 meter per second. At 1 second time, velocity is 10 meter per second. If you see, change in velocity is 10 here. So here the at time 2 seconds velocity is 20 meter per second. If you find out the change in this interval, it is 10. So it is equal to the previous one. We can say till here it is constant. Now see the next interval. Here we have at time 3 second, velocity is 30 meter per second. 30 minus 20 gives you 10. So change in velocity here is again constant. So acceleration is increasing but uniformly. Uniform acceleration is present here, or you can say constant acceleration is present here. And if you see this uh, line or this graph is increasing linearly, straight line we have in this graph. Each segment is of equal length, which is indicating that here acceleration is increasing but uniformly. Now let's see car traveling with uniform acceleration. If you see the data, at every second we have change of velocity, that is 10 meter per second. It is increasing with the increment of depth. So hope so it is clear to everyone. Here is the graph in which we have to deduce the information. See It is a constant line, and it is having zero velocity, 0 meter per second velocity, because there is no any jump on the vertical side. So car is at rest at this scenario, no acceleration is there, so acceleration is zero. So you can see from the this data table as well. So here are some practice questions, and you have to plot the graph, and same questions were given to you in previous lesson as well. Only the difference is that here you have to plot the graph of velocity time graph and car traveling with uniform deceleration. Now here you will have change in velocity that will be negative. So if you see, initially it was 55, 55 minus uh, sorry, this is initial velocity, here it is final velocity, so 45 minus 55 gives you minus 10. So and 35 minus 45 gives you minus 10. So it is also constantly decreasing. So you can say here we have negative acceleration. So it is also known as deceleration, and it is known as uniform deceleration because if you see, change in velocity is occurring constantly, that is minus 10 meter per second. I hope so you will easily plot this graph as well. And this was all for today's lesson. If you have any question, you can ask. And thank you so much. If you have not subscribed the channel, do it, and do not forget to hit the like button.